Hello everyone, welcome to lesson 38 of our GoLang course. In this lesson, we are going to learn about pointers in Go. Pointers have been considered a really difficult topic to understand in programming, but it has been made really easy by Go. So let's have a look at it. When you run a program, the operating system allocates a portion of computer's memory to it. This is where the program's instructions and data are loaded so it can be executed. Your Go program's memory space is logically divided into two main areas, stack and heap. The stack is a region of memory that is used for execution of function calls and management of local variables. The heap, on the other hand, is used for dynamic memory allocation, which allows for creation and deletion of variables as needed during the program execution. The stack is like a call history. It keeps track of function calls, local variables within those calls. When function is called, its information is pushed onto the stack. When the function call finishes, its information is popped off of the stack. The heap, however, is more like a free storage area where you can create and delete variables dynamically. It allows for more flexible memory management but requires manual cleanup in most languages. But the Go runtime, on the other hand, comes with a garbage collector. This means that the Go runtime system automatically manages memory allocation and deallocation for you. It keeps track of which part of memory are in use and which are not, and periodically reclaims the memory that is no longer being used by the program. This feature greatly simplifies the memory management for Go developers, as they don't have to manually allocate or deallocate memory like some other languages. If you come from the background of C or C++, you know what I'm talking about. Let's now discuss pointers. When you initialize a variable in a program, you are essentially reserving a portion of computer memory to store a specific value of a given data type. This allocated memory space is where the value will be stored and can be accessed later in the program. Pointers are special type of variables that doesn't store the value directly, but instead it stores the memory address where the value is located. This allows you to access and manipulate the value by using a pointer or the address of the variable. In Go, regardless of the data type a pointer points to, whether it's an integer, float, struct, etc., all pointers have the same size. The size of a pointer is determined by the underlying architecture of the system. It's usually 4 or 8 bytes in most modern systems. When a pointer variable is declared but not initialized, it has a default or the zero value of nil. Trying to access value stored at a nil pointer will give you runtime panic or runtime error. Now let's look at a small illustration of how all this works in memory along with pointers. As you can see, I have here variable names. Name is a variable of type string, is_even is a variable of type boolean, age is a variable of type int, and section is again of type string. Next, we have the variable values. Name stores A, is_even stores true, age stores 10, section stores B. When you assign a variable a value, it is given a space on the memory. Here we can see I've just simplified it and said A is stored at memory address 0, is_even is stored at memory address 8, age is stored at memory address 16, and section is stored at memory address 24. These here are the addresses of variables that we have initialized with these values. What's a pointer? A pointer is a variable that holds these memory addresses. If I create a pointer to name variable, it will store value 0, that is the address of the variable. Similarly, if I create a pointer to is_even variable, it will store the value of 8, that is the memory address of the variable or the value stored. Same is the case with age and section. If I create a pointer to age, it will store the value of 16, that is the memory address of age variable in memory. And last, if I create a pointer to section, it will store a memory address of 24 in the pointer. Now you may ask the question, how does pointer help? Since we have the memory addresses, we can manipulate whatever is stored at these fields directly. So using the memory address, I can manipulate data stored at this directly. This is a general view of how pointers and memory along with variables are used. Next, let us look at Go pointer operators. In Go, when you use the asterisk sign as a prefix before a variable type, it denotes that the variable will store the memory address or is a pointer. This means that the variable doesn't contain a value directly, but rather the location or address of where the value is stored, as we looked in the previous illustration. After you have created a pointer variable, you can use asterisk again to access value stored at memory address it points to. This operation is called dereferencing. It essentially allows you to work with the actual value that the pointer points to. In Go, the ampersand operator is used to obtain the memory address of a variable. This is particularly useful when you want to create a pointer that points to a specific variable. The address then can be assigned to a pointer variable. It is important to remember that in Go you cannot create pointers to constants or literal values like number of strings. Pointers are meant to hold the memory address of a variable, not constant or literals. Since constant and primitive literals are only created at compile time, so they don't have a memory address. As such, you cannot have a pointer store the memory address for a constant or a literal. We have talked about this before, but let us go over it again. A nil pointer is a pointer that does not point to a valid memory address. If you attempt to dereference or access the value pointed by the nil pointer, it will result in a runtime error or panic. This is because there is no valid memory location associated with a nil pointer, so trying to access its value is not allowed. Here I have a short code example of how pointers are used. First, as you can see here, I create a variable pointer to int, and with asterisk and int data type, I am saying pointer to an int is a pointer that stores address of an int variable. Similarly, next I have pointer to a string. Here with asterisk I am saying pointer to a string will store the memory address of a string variable. Similarly, I have pointer to bool. Here again with asterisk I am saying pointer to bool will hold the memory address of a bool variable. Herein, I create a variable age or int variable which stores a value 10. Then, to store the memory address or create a pointer, what I need to do is get the address of age variable. As you can see, I can do this with ampersand in the prefix, and this will give you the memory address of age, which is then stored onto pointer to int. What we see here is dereferencing. Since pointer to int stores the memory address of age variable, when I do asterisk pointer to int, it gives you the value 10. Now let us look at some examples. Let us first see how you can create a nil pointer. I can say var num is a nil pointer. If I try to do fmt.println and print the value of num, since we haven't stored any address in num variable, you will see when I try to run the program, nil is printed to the console. So let's run a program with go run main.go. And as expected, we see nil printed to the console. I'm just going to update the name to say num pointer or maybe int pointer, just to be clear what it stores. To get the address of a variable, we can use the ampersand sign. So here I have created the age int variable which stores the value 10. Then in int pointer, I will store the address of age. Now let's move this print statement below and see what the value is. As you can see, now we are getting an address in memory printed to the console. This means int pointer now has address for age. Now the third step is to dereference this value or get the value stored at int pointer. So if you have a pointer and you use asterisk sign again, you will get the value stored at that memory address. This process is known as dereferencing. So I can do fmt println dereference the value stored at int pointer. Let's run our program and see the output. As you can see, first we got the address of the pointer, which is the value stored in int pointer, and then 10 printed to our console, which is from here where we are dereferencing the value or getting the value stored at int pointer with asterisk in the sign. Asterisk in front of a data type denotes that the variable here is a pointer to that data type, but when you use asterisk with pointer, it gives you the value stored at that pointer address. As mentioned in the lecture, if I try to do this, where int pointer has a nil value, I will get a runtime panic. This is a very common mistake in valid memory address or nil pointer dereference. So whenever you get this error, try to go through your code and see where you are trying to dereference a nil pointer. Go compiler is helpful. It tells us we are trying to call this in main.go at line 7, which is where we are trying to dereference a nil pointer. This is a short introduction to pointers. We will cover more about pointers in the next few lessons. Another thing I wanted to mention, you can create pointers to any variable types except the primitive literals or constant. I can do name is code and learn, then I could create a name pointer, name ptr, store the address of name, fmt println dereference the value stored at name pointer. I just forgot to remove that. So now let's run our program again and see what the output is. As you can see, code and learn was printed. Similar to this, you can create pointers to any variable. But as I told you, you cannot do that for constant value or primitive literals. So I cannot do something like fmt println I want the memory address of 1. This is not possible, again because 1 here is not assigned any memory and it's a compile time constant. Don't worry if things are confusing to you at this point, because we will cover pointers in depth with examples and more code. Let's now revise everything we have learned in this lesson. We learned a pointer is a special type of variable in Go that doesn't store the actual value of a variable, but rather the memory address where the value is stored. This allows the program to directly manipulate the value stored at that memory address. In Go, regardless of the data type a pointer points to, all pointers have the same size. Again, this size is dependent on the architecture of the system where our program runs. Usually, it's 4 to 8 bytes on most modern systems. Then, we looked at the pointer operators, that's the asterisk operator and the ampersand. The asterisk is used to declare a pointer variable and also dereference a pointer or access the value the pointer points to. On the other hand, ampersand is used to obtain the memory address of a variable, which can then be assigned to a pointer variable. That's it for our lesson. Please feel free to leave a comment under the video if you have any questions. Thanks for watching. I hope you enjoyed the lesson. I will see you in the next lesson. Happy coding.